All right, we are live on Super Bowl Sunday, but not my Super Bowl, right? Not over it yet. All right, so you are in what, week 5? Wow, just moving right along. Actually, this is a very, 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 very important week, as far as understanding what z-scores are. And I'm going to do one little example here. And then if you need some of the other problems worked, please don't forget that you can click that Ask My Instructor, and I can do a nice little video like this showing you how to get through the problems. So let's just look at something like this to kind of get the understanding. The first thing here they're asking me is just find the positive difference. So it says, Vincent has a height of 60 inches, was the shortest president of a particular club in the past century. The club presidents of the past century have a mean height of 61.4 and a standard deviation of 1.4. I know you can read too, right? So what is the positive difference between Vincent's height, 60, minus 61.4? Now we know we don't need a calculator, but let's just check ourselves. All right, it says the positive, so you're going to absolute value this. So of course it'll be negative 1.4, which absolute value would be 1.4. Happy? Happy. Okay, part B. How many standard deviations is that, the difference found from part A? So what you do, kind of nice, is what you do in this one is you take what you found in part A. So let me write that's part A, because the reason why is you divide by the standard deviation. How bizarre, right? And so you get 1. So that's 1 standard deviation from part A. All right, convert to a z-score. So again, z-scores are so important. You got to understand z-scores because you're standardizing your data and you're going to see to be able to look up in a probability table. Otherwise, you'd have to have a table for somebody with a height of 59 inches, somebody for a height of 61 inches, somebody with a height of 97 inches, whatever. And so the z-scores, what we're doing is there's this nice little formula to standardize that it's your x value minus your mean divided by the standard deviation. And in this case, our x value, our data value is 60. They told us the mean was 61.4 and then divide by 1.4. So if you notice, that's kind of what they were doing, is walking you through these steps, except you're not going to, in this case, absolute value the top. You're just going to leave it that way. So we know that was negative 1.4. We know the bottom's 1.4. And we get negative 1. So it says if we consider unusual heights to between negative 2 and 2, is Vincent's height usual or unusual? Well, let's get you in a habit of starting to say, if this is from a normal distribution, your bell-shaped curve, and then right down the middle is the mean that they give us, 61.4. And what they're saying is that, Vincent, he's below the mean at this 60. And so what we're doing when we're standardizing is, let me get me another color right here, color. Let's go orange. Is when we're standardizing our, it doesn't look like a different color, does it? We're standardizing to a z-score of a mean of 0. And so this is saying that I'm 1 standard deviation below the mean, okay, because I've standardized it. And now what they're asking me is these cutoffs here, am I in these cutoffs, which would be certainly further down, like here, negative 2 and positive 2, and did I end up in those areas? And I did not. So this certainly, he's not an unusual height, I guess. Way to go, Vincent. Again, you're going to really need to start drawing the pictures and figuring out, what are they asking me? Why am I actually doing this standardization of these z-scores? And remember, I'm here to help you. So if you need any help, I will be around for the week, and feel free to hit that Ask My Instructor or shoot me an email. I'll see you online. Have a great week. And remember, not my Super Bowl.